Hi, this is Jill for Chibitronics, and this video is going to be different than the tutorials that I usually create. In this video, I am going to show you how to use a multimeter to measure the voltage of a coin cell battery. And also, I'm expecting that we'll find that even though some of the batteries might appear to be fresh when we measure the voltage with the multimeter, when we do some experiments with actual circuits, we'll probably discover that at least one of the 5 of these batteries is not as fresh as expected, even though it hasn't been used and is coming out of a package that hasn't been open. Because I don't know how old they actually are. I don't know how long they've been kicking around my house or the factories before I got them. So I actually went through my stash and found 5 different ones. So I just want you to know that this Sony one is actually brand new, even though the packaging is sort of open. I haven't used it. All right, so the first thing that I want to do is to show you 2 different types of multimeters. Okay, so this first one is called an auto-ranging multimeter. An auto-ranging multimeter is more expensive than some that are available on the market. One of the functions of it is that you don't have to think quite as much about what you're doing with it, I think. Now that's the reason I really like it. But basically how it works is you're going to put the black test lead into the COM port and the red test lead into the port that has the symbols for voltage, capacitance, etc. So we're keeping everything on the right side of the multimeter. So when we use the auto-ranging multimeter, we will be turning the dial to the VDC option. VDC, you can see it right there. And then we'll be using these test leads to test the voltage. All right, so I'm going to put this over here for a second. And so the other type of multimeter is called, well, it's a digital multimeter. So this one was about $20, not very expensive. It gets the job done. Same thing. You're going to put the negative test lead into the COM port and the red test lead into this port that has the voltage and resistance, voltage and ohms measurement. Okay. And so for this type of multimeter, we're going to set it to a range. So we're going to put it at the upper end of the range between what we expect the voltage of our batteries to read. Since they're 3-volt batteries, I know they should tend to read higher than 2 and lower than 20. So that's why I'm choosing to aim it at the 20. And I would just push this button to turn it on. All right. So I'm actually going to use this one just for demo purposes. It's doing I don't know exactly what it's doing. It's doing its own thing at the moment, but these readings they don't mean anything to us yet. All right, putting the multimeter to the side, turning it off for a moment. So let's start with the first battery. So here's my Sony battery. I'm going to test it for voltage. So the first thing that we're going to do, once again, set your multimeter to VDC, and then we're going to take the negative test lead and put it in the center of the battery. This is a little bit hard to do with all of this stuff on my desk. And the positive test lead on the edge, because the edge is positive. All right, so this Sony battery is measuring at 3.221 volts. So I'm going to go ahead and write that down. 3.221 volts for the Sony battery. All right, next we're going to try a Green Max battery. Okay, this one, the adhesive on the packaging is a little loose, but this is a brand new battery, never been used. Green Max. All right, so same thing. I'm putting it with the negative side up, the negative test lead in the center of the battery, the positive test lead on the positive edge. and this battery is measuring 3.303. So green max is 3 point, what did I say? I've already forgotten. 3.303, is that what it was? 3.30. 3.303 volts. Green max. Okay. All right, then we have this battery, Lisbia. Same thing, we'll put that negative test lead in the center, positive test lead to the edge. 3.325. 3.325 volts. Okay, here's another one. I can't pronounce that one. Okay, this one. 3.303 volts. 3.303 volts. Okay, and then the last one is this one. What? I don't know how to pronounce that. Okay. All right, so these batteries are coming out of my stash. That means I've purchased them from a variety of different places. Some of them on Amazon, others from other resellers. Okay, 3.326, 3.3, 3.326, 3.326. Okay, so based on the measurements of these batteries, they're all as I would expect. They're all over 3 volts. I don't actually, so just because they read over 3 volts doesn't mean that they're gonna work the way that they should. But this first measurement that we did with voltage is telling us that the potential for these batteries is good. All of these batteries should work as intended, unless they're not fresh, unless something happened to them, unless they're really old, or they were stored in a really hot warehouse somewhere. And so we don't really know, but the potential for these batteries is good. They've all measure over 3 volts, so they should be able to light the test circuits that I've created. So all of Chibitronics LED stickers can be lit with a single coin cell battery, assuming that the battery is fresh. So I have here a circuit that has 2 yellow and 1 white LED. And I put a patch on this white LED because it wasn't making enough physical contact with the copper tape above it. And so it was tending to flicker, in particular when battery voltage wasn't strong enough. I haven't actually tested these yet, but in using other batteries. So for example, I'll show you a really weak battery before we test all our positive ones. Okay, so this battery is really in bad shape. Okay, let's move that multimeter back up. Okay, so this battery is currently measuring 2.557 volts. So I already know that this battery, it's less than 3 volts. I'm not expecting much from it, but I'll show you how a battery, but I know that this battery doesn't have good potential. All right, so this battery is probably not going to work well. So I'm going to just quickly show you what this battery would do in the circuits that I built. All right, I'm expecting these 2 yellow lights to turn on and not the white. And that is exactly what's happening. Because there isn't enough voltage for all of these LEDs to light up. In this one, I'm expecting only the red LEDs to light up. I don't know if you can see that that's what's happening. In this one, I'm expecting that the white ones will light up dimly, if they light up at all. They're not lighting up at all unless, okay, they're lighting up. You can't see it probably. There. Okay. Really, really, really dimly. But that, I mean, horribly, not really lighting up. This battery is really weak. In this one, I'm expecting the red and yellow to light up, maybe orange, but nothing else. Okay, here we go. That's exactly what's happening. So this battery is an example of a battery that didn't have enough potential. It behaves exactly as I would expect. All right, so now we're gonna test these other batteries. And I'm actually a little bit nervous, so we'll see how this goes. All right, so I'm gonna start with the Sony battery, 3.221 volts. I'm actually gonna start from the bottom and work my way up. All right, so I'm putting this one in. I'm expecting everything to light up. Well, that's good. Let's see, how about this one? That's good, working as expected. That one's working as expected. And that one's working as expected. All right, so the Sony battery is working as we would expect. All right, Green Max. This one measured in at 3.303 volts. Okay, this one's working well as well. Although at first I wasn't sure. Huh. All right, here we go. Here's this one. Yep, it's working. Working as expected. Working as expected. Okay, then the Lisbia battery. That one's good. That one looks good. That one looks good. This one seems like it's working a little better than the other two, so I'm putting it over to the side. All right, this one is a I don't know how to say that. Here we go. All right, here we go. All right, this one had measured 3.3 volts with the multimeter. And it is behaving similarly to the first one I showed you. This one. Do you see how only the red LEDs are lighting up here and down below only the yellow? This is an example. Okay, this one's better than the one that measured at 2.5 volts. But this battery is showing a perfect example of taking a battery out of the packaging, testing it with a multimeter, having it measure over 3 volts, but then it behaves in an unexpected way. So there's another test I can do on this, which is called testing for voltage under load, which I'll do later. But this battery is definitely not a good one. So just putting a little note there. All right, last one is this Hua battery. Stick it in here. All right, that one looks good. That one looks good. That's good. That one's really good. Okay. So actually these two are the brightest of the 5. So I made this with a test lead. This is just like a jumper cable that I just cut into half, cut into 2 pieces, and then I stripped the edges. So I have these 2 pieces of jumper cable, and then I took the 470 kilo ohm resistor and just twisted it. You could solder it if you wanted, but twisting works okay. So I'm twisting the metal leads of the resistor around the wire, the metal wire of my test lead. See that? Okay. Again, wrapping the wire around it. and then I wrapped it with washi tape. You could also use electrical tape. I happen to have more washi tape in my studio than electrical tape. So I'll just show you. So I just take that washi tape and I'm wrapping it around to insulate that resistor and hopefully keep it from coming apart. Okay. Most people probably don't have these things laying around in their workspace, but I still wanted to just do a quick demo so you can see something instead of taking my word for it. All right, so this guy is the same as this guy, and then I just attached some alligator clips to the bottom of it. So that I can grab onto the multimeter. All right, and I'm going to take so I have the negative, actually it's not negative. So the resistor doesn't have polarity to it, so it doesn't really matter whether I connect the black to the black test lead or the yellow or the red to the red test lead. All right, but that's how I'm doing it. It wouldn't really matter if I didn't. So I'm attaching the resistor to both parts of the multimeter. Okay, so that resistor that I showed you is in between the two test leads. So the one that we were thinking was the worst one was this one. Let's try this one first. So just to double verify, so this is the one that only lit the yellow. All right. So here we go. We're gonna put it so we have the negative. All right, do you see that in the corner? Move this up a little bit higher. So the battery that we're looking at is this one. It measured at 3.3 volts, but now under load, so put the negative in the center, the positive test lead to the edge. Look. It's measuring under a volt. Okay, this is a really bad battery. So it's measuring under a volt. So it measured 0.9 volts. Okay, and then the other one, I think that was the worst one, right? Let's double check it. So this one was the bad one. And those were good, and these were good. Okay. Well, there you have it. So I'm going to take these clips off again. And measure that bad battery. And it's 3.24. So to recap, when we tested the circuit without using the extra load of a resistor, all of the batteries measured over 3 volts, and we expected that they would work well. Then when we discovered that one wasn't working well, this one, we tested them under load. And all of them were working well except for this one, which tested under 1 volt. So this battery is behaving the way that I would expect it to based on the load testing. If you don't have access to a multimeter, You can use a test circuit such as the one that I've got here, and you can just put batteries in it and test out the different configurations of lights, and you can get a pretty good idea of whether or not you've got a good battery or not. If you're not sure, you can use patches to try to improve the physical and electrical connection between your stickers and the circuit. You can also try removing any colored LEDs from the circuit and just use white. Another thing you can try is stacking. Actually, I'm going to make a note on this one. I'm going to put a D for dud. And I'm going to pair it with this other dud that we had. Try double stacking the batteries. So let's see if that makes any difference. Still not enough voltage in this. No, not much. Sometimes stacking batteries can help though. I hope this video helped to demystify multimeters and help you understand some ways to debug a circuit that might be suffering from a lack of voltage. And remember, a multimeter is your friend. For more details, visit Chibitronics.com or visit the links in the description below.